Again, these lectures cover the multiple regression. Our main objective is to use the technology to find a multiple regression equation, also the standard error of estimate, and the coefficient of determination. We're also going to use the multiple regression equation to predict Y values. So in our previous lectures, we covered a simple linear regression where we said only one independent variable determined the dependent variable. Also, we saw an example where we said the company expenses or total expenses on advertisement would determine the company sales or the revenue they generated. So in many instances, a better prediction can be found for a dependent variable by using more than one independent variable. And this is the concept of multiple regression. So again, the previous lectures, as we said, a more accurate prediction for the company sales can be made if we also consider the number of employees on the sales staff, as well as the advertising expenses. We know that advertising expenses can have effect on the company's sales, but also it may depend on the number of employees they have on the sales staff. So this will lead us to the concept of, again, multiple regression. So the equation is the same as a simple linear regression, but here we have more than one independent variable. So for example, we have the B, which represent the y-intercept, M1, X1, M2, S2, M3, S3, up to MK, SK, which means we have K number of independent variable. Each variable, independent variable, is its own slope. So here we say S1, S2, S3, up to SK are independent variables. And also B is the y-intercept, and Y is the dependent variable. Now, because the mathematics associated with this concept is very complicated, technology is generally used to calculate the multiple regression equation. Also, the data will be very large. For example, here we have, let's say, 10 independent variables, which means each of these 10 variables have its own data. So we may have a very large data set. So technology is the best way to use. So here we have an example here saying that a researcher wants to determine how employees' salary at a certain company are related to the length of employment, also the previous experience and education. So here we have three variables. Employee salary may relate to the length of employment, also its previous experience and education level. Now, the researcher selects 8 employees from the company and obtains the data shown on the next slide. Here we are going to use the Minitab to find a multiple regression equation that models the data. So this is our data. We have X1 as the employees, number of years. X2 is the experience, number of years. S3 is education, the number of years spent. And each employee have his own salary. So our independent variables are X1, S2, S3, and those 3 variables will determine the employee salary. So we enter the Y values in C1, and X1, S2, S3 vary in C2, C3, and C4, respectively. Then we select the regression menu with the regression from the start menu. Then we use the salary as our response variable, and then the remaining data as the predictors, which is the 3 variables. So this is what we get using the Minitab. Again, this is our X1, S2, S3 values. They are coefficients, standard error, and their p-values. But again, when we use the Minitab, this is the regression equation we have: 49764 plus 364 X1 plus 228 S2 plus 27 S3. And that's the regression equation. Now, predicting Y value, after we find the equation of the multiple regression line, we can use the equation to predict a Y value over the range of the data. So this means we have to know the value of S1, S2, S3, then we can predict what Y value is. And here we have an example, the number of years, 12, and the second is 5, and the third is 16. So this means the employee salary prediction will be 59,544. So this section gets summarized concept of using multiple regression using Minitab. Now in the next section, I'm going to use Microsoft Excel, which is one of the famous common software we use for data analysis. So here I have an example of a data here, X1 and X2. Again, the independent variable can be as many as we want. And my dependent variable is Y. So if I want to come up with the solution, in this case, I'm using multiple regression. Why? Because the independent variable is 2 or more, S1 and S2. So the first thing I'm going to do, I'm going to use the data analytics. So so here we have the data analysis, which is the plugin. So I'm going to click on it. Then I will select the regression. And I will click OK. So first is my Y range, which is my dependent variable. In this case, it's going to be C2 to C6. Again, I don't want to use the label. Then next will be my dependent variables. So this will be my dependent variables. And here I'm going to use, I have A and B, so I'm going to use both columns. Now, since I didn't select the label, I don't need to select it here. The confidence level, we leave it as default 95%. And our output will be on a new worksheet. We can also include the residuals. We discussed the residuals in our previous lectures. Normally, it's the difference of the actual Y value and the predicted Y value. And if we like, we can also add the normal probability plots. Then we click up. So this is our solution. Here we can see our data here. We have a multiple R, and that gives us 0.641904. Then the R square, again, we square multiple R, we get 0.41204. So R square is our coefficient of determination, and the R is our correlation coefficient. And then we can come up, we look here, we can see, again, this is for now, it's not part of our solution, but we also have the ANOVA we can select, and also the residual output is given here for each. And also this is my normal probability plot. So that would be the conclusion for this section. And normally also here we can see we have the y-intercept, the first row. We have the variable 1 or x1 and x2 values. They are t-stat, p-value, etc. So that would be the conclusion of these lectures. And again, see you in our next lectures.